Now, hello everyone, and we will start today's discussion with the topic that is called as screw gauge. Earlier occasion we have already done the vernier calipers. Now today we will going to start this we have done. Let's have a very quick review. What we have seen: the vernier calipers, screw gauge, and screw gauge. We have seen the least count, and we have derived the formula of it, and how we'll take the reading of it. Now we will going to start new device name screw gauge. Screw gauge. Now the basic structure of screw gauge, as you have seen in figure 1.9 above slide. So let me quickly draw you the shape of it. So this is U-shaped frame, and U-shaped frame, there is one rod tie stuff that is called as spindle, and it got this rod, it is attached to, and here some reading is there. In that particular scale, it is called as main scale. And through this main scale, there is one more scale attached that is called as, this is called as circular scale. As you can see in upper slide, there is some baseline that is called as main scale, and there is some circular point. It is written 95.0, and here you can see this is the circular scale. Fine. And there's a two zeros. There's one circular zero, circular scale 0 is there, and the main scale 0 is there. So then after, this is connecting with some rotatory device that is called as ratchet. Now ratchet, the function of ratchet, it keep rotating it so the main scale and circular scale can work properly. This is the structure of screw gauge, and here we can say once we have rotating it, the each and every groove it got rotate on it. So there's one term that is called as pitch. Now pitch is defined as the pitch of a screw is distance move along its axis by screw in one complete rotation of its head is once it rotate by one rotation, what the linear distance it has traveled with. And usually what we have seen that it traveled, pitch is usually 1 mm, tense covered. This is usually, but you can decide pitch by the question situation. Now let's take least count. The least count in case of vernier it is defined at pitch pitch of a screw divided by total number of division on circular scale. So pitch is defined as like least count, it is defined as pitch divided by total number. So usually the pitch is 1 mm divided by total number on circular scale is 100. So it will comes out to be 0.01 mm, or we can say 0.001 centimeter. So this is called pitch and least count of a screw gauge. Now the next important thing is how we measure the total reading of it. So once again, reading somewhat very much similar. What we have seen, reading of total reading, to here total reading would be main scale. So here main scale remains same plus P, that is coinciding with, now here the column that is coinciding with main scale. Let's say in upper diagram which column is coinciding. Here we can say this is look like fifth column, it is coinciding. So P multiply by least count minus again 0 error. So total reading formula, it will remain same in both of the cases. So total reading would be main scale plus column that is coinciding multiply by least count minus 0 error. Fine. Now let's quickly see few question that is based on it, but before that let's quickly see next article, 0 error. Now for the sake of 0 error, let's divide it in vernier and screw gauge, vernier calipers and screw gauge. Now for the sake of vernier calipers and screw gauge, let's quickly see the screw gauge. Now here you can see the diagram 1.9. Look at the baseline. The circular scale 0 is just below like this is the main scale, and circular 0 is below the main line. So that is supposed to be called as positive error. There is positive error. Fine. Positive error. And in case of negative error, so how we'll calculate the zero error? Let's say whatsoever, like earlier situation, in the fifth column it is coinciding in figure 1.9 in upper slide, multiply by least count, and least count is, let's say, 0.01 mm. So once we multiply, so the zero error will be plus 0.05 mm. And the next situation is when the, now here you can see negative error. This is negative error where the 0 is just above the baseline. One just above the baseline, here we can say 95th column it is coinciding. So how will express the 0 error? To minus 100 minus 95. When the, like, let's say total circular scale there is a 100 column. Once 50 column it will cross, so you will use the formula 100 minus 95, multiply by 0.01 mm. It will comes out to be minus 0.05 mm. This is in case of circular scale and screw gauge. So how many zero error are there? Positive zero error, when 0 is below it. And how we calculate? By this way we can calculate. And in case of negative error, we can say 100 minus 95, and we can easily calculate as I have shown in the given diagram. Similarly, we can do in vernier case. Here the diagram 1.4, you can see easily when the vernier 0 is ahead, like earlier what we have seen, the vernier in the case of screw gauge one, it is ahead, it is called negative, but here when the vernier scale is ahead, that is called positive error. And whatsoever number, like here 6 column is coinciding, 6 multiplied by least count. By this way we can get the positive error. Now here we can say negative error, one it is lagging, vernier calipers 0 is lagging with main scale 0. So that is supposed to be called as negative error. So I thought all those discussion will really give you the sense ki how we calculate zero error. Fine. So now the next slide we will see the question that is based on it. Till then, take care.